Hello all, my name is Divya. For the final week of Teach One, my topic is on model building in logistic regression, specifically on propensity scoring. So, what is propensity scoring? Propensity score is a predicted probability of assignment to a particular treatment given a set of observed covariates. Propensity scores are used in observational studies to reduce bias by balancing covariates between treatment groups in order to estimate causal treatment effects. Actually, logistic regression predicts the probability of an individual receiving treatment, while propensity scores use these logistic regression probabilities to balance and equalize them between groups, which enables less biased comparisons. In this question, we will identify candidates for hospital admission based on patient assessments and demographic data. The data have been collected on various aspects like age, gender, assessments completed, days followed, disabilities, mortality status, etc. This information is crucial for identifying residents who may benefit from hospital care. By using logistic regression, modeling technique, and propensity scoring, we are predicting patients' mortality in nursing homes. In our case, we'll use logistic regression to predict whether a resident is likely to die based on their age and disabilities at the time of assessment. Propensity scores estimates based on observed characteristics. By combining logistic regression with propensity scores, we ensure a comprehensive approach, making our predictions more reliable. This modeling strategy allows us to not only predict patient mortality but also helps in making informed decisions about hospital admission. Coming to the code, firstly we load our data. The data set contains information about nursing home residents. We replace these column names such as ID, age, gender, unable to bathe, unable to toilet, etc. This step helps us to understand and work with the data effectively. Coming to step 1, data cleaning, checking for missing values. This code performs by checking for missing values in our dataset. This is crucial because missing data can impact our analysis. Luckily, we don't find any missing values, ensuring the integrity of our dataset. Coming to step 2, changing age into categorical variable. To better analyze age, we create new variable like age at assessment is a variable by considering both age and the days since the first assessment. Coming to step 3, creating a function that categorizes ages into decades. To simplify our analysis, we categorize ages into decades using a custom function, making it easier to interpret age-related patterns. We map each unique age decade to a binary column, effectively performing one-hot encoding. This technique creates a clearer representation of age groups and simplifies our analysis. And fourth step includes missing values in the gender column of the nursing home are replaced with 0. Subsequently, a frequency table is generated to count the occurrences of each gender in the database. In the dataset, the most common gender is identified. As you can see, male number is more than the female number. The most common category is male. And next step, handling missing gender values. To handle missing gender values, we find the most common gender in the dataset. In this case, It's either male or female. We then convert gender into binary variable, where 1 represents male and 0 represents female. The sixth step includes creating a subset data frame. We are simplifying things by making a new list. Nursing home data that only includes the important important stuff. This focused data frame is like a toolbox for building our predictions, highlighting the factors that really matter in our analysis. Starting the logistic regression model, now we are diving into the core of our analysis. Using logistic regression, we are predicting the chance of resident experiencing mortality. Our model considers various factors such as eating habits, walking abilities, age, decades, and gender. It's like looking at a puzzle to understand and predict what might happen in the nursing home. Now, understanding model summary and propensity scores. Next, we check how well our prediction model fits the data. We take a closer look at the model summary, trying to understand its performance. Additionally, we calculate propensity scores, which help us estimate the likelihood mortality for each resident based on our model. It's like fine tuning our predictions to get a clearer picture. Next step, we do balancing data with inverse probability weights. To make sure our analysis is fair and unbiased, we introduced inverse probability weights. These weights consider differences in the likelihood of mortality among residents, providing a balanced view of our data. It's like adjusting our lens to see things more accurately. Finally, we are applying weights to build a linear regression model. We use these weights to construct a linear regression model. This step further polishes our predictions by considering each resident's unique characteristics, as you can see. Now we completed our final analysis and interpretation.